On the left, we see a shipping manifest. And on the right, we see JSON that represents that shipping manifest. So there's a natural question. How do we turn paper documents into JSON that we can use in our Python scripts, in our programs, in our databases? So I'm James, and today we'll be chatting about how to fine-tune SmolVLM2 with custom dataset for document processing. So before we get started on fine-tuning, let's give some background on multimodal models, of which SmolVLM2 is one. The multimodal models with image capabilities let you ask questions about an image. We could ask about this shipping manifest on the right. What's the route number? Describe the image. Who's the document author? What's the pallet total? Is there paper in the image? We can ask all these questions. Now, this is something that we've become familiar with say, ChatGPT, but there's an alternative to running a big model in the clouds and sending your data there. And that's fine-tuning an open source one that you can run on your own infrastructure. So that's where SmolVLM2 comes in. SmolVLM2 was released by Hugging Face earlier this year. It's multimodal and has both image and video capabilities. Now you can ask SmolVLM2 about contents of an image or video, and then it will return that answer to the question. Now, luckily for us, the topic today is fine-tuning SmolVLM2. So we'll be talking about how to kind of take those base weights, send data which matches pairs of images to questions and answers, and then run that fine-tuned model to get information in the format we want. So in this case, documents to JSON. Now, by fine-tuning a multimodal model, you get more accurate results on your task and input data. And then also, in an open source case, you can host your model on your own infrastructure. Now, for SmolVLM2, we're really looking at a cloud GPU or a local GPU for running, whichever you have available, like a T4 and L4 type GPU or larger if you have one. So how do we fine-tune a VLM? What are we going to be talking about? So the flow for fine-tuning of VLM is basically the same as object detection or classification. You label your data, get some ground truth, you prepare a data set that you'll use to fine-tune your model, and then you will run a fine-tune job. And in this case, we'll be doing it in the clouds with one click, which is great. And then we'll be deploying that SmolVLM2 model. And then part of deployment is building our application logic. And for this, guides will be kind of walking through combining two different models, a classification model and also a SmolVLM2, so we can build some writing logic on top of our base model. So yeah, reminder, we're going to take this shipping document and turn it into JSON. And with that, let's train a model. So if you go to rubbleflow.com/SmolVLM dataset, we've got a dataset available. You can also Google Rubbleflow Universe Palette dataset, and we're going to kind of use that as a base for our project. So to get started, if you go into Rubbleflow and create a new project, we're going to call this, let's say, shipping palette and documents shipping. We'll say orientation group is, and then we'll choose a multimodal project. And this project type you can use for fine-tuning Florence 2, Quinn, and Polygamma, and also for this SmolVLM. I'm going to create this project. And then the first thing we need to do is set up a prefix. Now, you may have heard of like the question answer pair thing in multimodal models. Rubbleflow calls it a prefix. And the reason for that is there are many models that do it different ways, and we chose kind of the polygamma type terminology. Basically, a prefix is your question, and then that has an associated answer. And the prefix you choose is what's going to be available in your labeling. Now, you can have as many of these as you'd like, but for this task, because we're really doing like we're translating a document into a specific format with specific keys, we're going to, instead of do a question, we're going to kind of do a token. So we'll set JSON as our prefix. And then when we prompt the model with this, it's going to use all the knowledge it learned from our fine-tune to return that JSON. So I'm going to add that prefix. We've got that set up. And then next up is dataset preparation. For this, we can upload some data. Now I've actually already got this dataset of palette images. So 170 images here. I'll upload. And then very quickly, this data will be processed, sent to the cloud, and then we should be able to start labeling. And the labeling process for multimodal data sets is slightly different than others. So whereas previously we would kind of draw a bounding box or give a classification label, we're going to be answering questions. For data sets here, if I go into annotate, you can see there's already lots of images labeled, and we've got one unlabeled, which I'll go into here. Now we'll click annotate images. We'll start labeling, and then I will take responsibility over this one. So in the annotation editor, this is kind of the nuts and bolts. For any multimodal projects, you'll have prefix, suffix, question, answer, and then here's where you would put your data. So for this, we might say something like palette total, and then say 82, and then maybe something like load is 2, and then we'd really put in all of our data here. We will translate this whole document into JSON, and that can have keys, values, that can have lists, everything that you need. And I'm not going to label this whole document, but when you do have a fully labeled set of data, we can go in and take a look at this. And you can see we've got the root number, the palette number, everything we need, and also that list of products which maps to the table. I'm going to prove, I'm going to hit prove on all these images. We're going to use all these in our data set. And very quickly, we are almost ready to train our model. So when you're preparing multimodal data, you may be wondering, do I really have to type in all that JSON? Well, one technique I would recommend is if you're kind of building an application for data entry, for example, you can ask people to enter data and then also have like a take a photo section. And so you already in your database are going to have photos of documents and the translation of documents, and you can just upload that to RoboFlow in our API. We accept JSON-L as kind of our standard format for multimodal. So lines of JSON, very simple. Once you've got the data, you can bring it in for training. Next up, when we have our data set, we train a model. Now, traditionally, we would create like a dataset version, which is basically a snapshot of our model right now. This is the data we're going to use for training. Part of that is pre-processing. We'll make sure all the images are standard, resize, auto-orient, that kind of stuff. And then after that, we for like object detection, we might create augmentations. But for this project, we don't really need them. So I'm going to hit create, and then some work is going to be done in the background to create a dataset version. And then next up, this is the fun part, the part we've all been waiting for, is training. And I like buttons to train models because I prefer to spend my time coding like the advanced part of an application logic. So I'm going to hit train. And then here we choose what model we want. We support a couple different multimodal models. The one that we'll be doing today, SmolVLM. With that said, I encourage you to play around, experiment with different models. We've got tutorials on training all of these. SmolVLM is slower than some of these other ones. With that said, especially for asynchronous processing use cases, that's totally okay. And we'll hit continue, and then we can choose what model we want. SmolVLM now has 2 versions, number 2, and then the first one, which is their first series, of which we took the 256 million parameter one. We've actually slightly changed that, and we're using like a LoRa, which basically means model's going to be smaller. It's going to fit on a GPU easier and reduce the risk of an out-of-memory error. So we'll pick SmolVLM2 LoRa, click continue, and then I'm going to click train from pre-trained weights. It's going to use our base LoRa's, and then start training. And then this is where all the magic happens in the background to get us to a train model. And for this, it's going to take 4 hours on this data. That's because fine-tuning multimodal models takes a lot of compute. But thankfully, I prepared one earlier that we can start building something away. So we've got this palette loads manifest, of which got a couple different versions. I trained a Florence 2, and then I trained a couple SmolVLMs. When you're training a model in RoboFlow, you get all the training graphs you'd expect. So we've got loss here, we've got perplexity, and some advanced ones too. And then generally for these 2 metrics, as long as they're going down and to the right, we're happy. And the further down they go, the better. So you can kind of see that data in RoboFlow, but the question is like, okay, we've got two graphs here. How do we turn that into insights? How do we turn that into our application? And for that, we are going to run our model on the cloud GPU. We could also run our own on our own hardware too, but my Mac isn't a T4, unfortunately, although maybe Apple will make one day. So I'm going to go to deployments. And with RoboFlow, you can spin up a cloud GPU in like 3 clicks. I've got one that I've already prepared called shipping, and I'm going to hit play on that. But when you start a new deployment, you can choose CPU, GPU. Do you want one that's temporary or permanent? And then kind of set a couple specs on your dedicated deployments. And this is something you can rely on for production. And so your model weights are going to be on there. We can ping, make requests, run our model, or again, run it on your own hardware. But while that's spinning off in the background, let's actually build the app. So I'm going to go into workflows and hit create workflow. The workflows is where we build the engine behind our application. I'm going to call this one something like shipping documents. It's safe. And workflows can combine any of dozens, actually more than 100 different computer vision primitives, both multimodal models, detection models, consensus algorithms, video tracking, detection smoothing, really anything you need to build an application. Sometimes I just come here, spin up a new workflow, plug in like a universe model, and of which there are thousands that are open source, and just play around, see what I can make. But for this, our engine is going to be SmolVLM2. But earlier, I kind of mentioned that SmolVLM2 can be quite slow. So how can we like do something about that? One thing we can do is add a classification layer before we even run SmolVLM2 and just be like, hey, only run SmolVLM2 if this image contains a document, or only run SmolVLM2 if this image contains whatever object of interest. Now, for a production application, I'd really be training like a ResNet that classifies like which model do I want to run? Do I even want to run my multimodal model? But for this, I'm just going to choose good old clip, and I'm gonna go to the side here and add a clip comparison. I'm going to take my input image and then do 2 classes, document and let's say table. Let's say that some people are taking photos, or you've got stored photos and some are just tables and not the actual documents you're scanning. So this is going to return which is the most likely class. And I will plug that into our output so that we can see our clip comparison. And then let's choose the most similar class. So let's save that. And then maybe let's do a demo of this. I'm going to delete SmolVLM. I will test my workflow. And I'm going to upload this photo I've got of the shipping manifest. This will take a while to run. And here we're just going to say, like, does this image contain the document or a table? And here, document, great. And then if I upload an image of a table where there should be a document, hopefully we'll get not document or table. And the close seconds. And we also get document. This is why we train a ResNet for this. There's definitely a little bit of like clip engineering we do. Let's try like not document. Sometimes negation works with clip. Let's see what we get. Okay, not document. Perfect. Okay, so this is not a document. Let's then go in and run SmolVLM. So I will, or sorry, one more thing. We only want to run SmolVLM if our thing contains documents. So here we can use classic if statement, and like in any programming language, we call it continuous. And then we'll set a condition which says if our classification predictions of the top class is documents. So if clip says, hey, this image is a document, let's run the next step. And then continuous needs something to do next. And that finally is SmolVLM2. And before we set that up, I'm going to go up to the top left here and choose that dedicated deployment, that shipping one that we set up earlier. I'll hit connect. And then all this workflow stuff, Clip was running on our serverless cloud. Now it's going to run on our dedicated deployments. This is a GPU specifically for us. And then we can spin up more of those if we ever need this. Now, when you're setting up SmolVLM2, you can choose base weights, or you can choose all the models you've trained. I'll choose that number 4, the most recent one. And then the prompt could be your question, like what's in the image or whatever you want the question to be. But for this, because we fine-tuned the model, we can use our custom JSON. So I'm going to hit save on that, and then also make sure to choose our input image, because SmolVLM needs an image to work. And then now we can run an image. So this bit takes a little while. When you have cloud deployment set up, the first thing that happens is the weights are going to be downloaded and set up on that system. They'll then be cached. The weights will be loaded into memory, and so that step will happen. And then finally, we will get a response. With that said, while we're kind of waiting for this, I do want to talk a bit more about this kind of pattern of Clip and SmolVLM. And one thing that you may have seen with cloud APIs in particular is like they're expensive. And SmolVLM is expensive, but in a slightly different way. It takes time to run the model. So when the model weights are cached and such, it might be 15 seconds on a T4 before you actually get a response. So the question is like, how do we minimize the number of requests going to our model? And for that, that's why we're using Clip here. And I think increasingly, like I've seen some people do even text tasks where they're like, how do I reduce the amount of text I send to an LLM? Or how do I make sure I'm sending the right text to an LLM? And that's where these kind of steps happen. We do Clip, continue, then SmolVLM. And yeah, for production applications, I train on ResNet, and really the smallest, fastest I could run, and I would tag that onto this workflow. And then, so I'd throw my image, I'd run a ResNet, I would get SmolVLM2 to parse the results, or if applicable, and then I would get the output. I'm going to upload another image because sometimes it gets hanged in this process of caching the weights and such. So I'm going to let that run. But yeah, SmolVLM2 in particular, I like for this task, firstly, because it's open source. And secondly, running multimodal models for document processing kind of increases the reliability of like you getting keys in the right structure that you would expect and values in the right structure that you would expect. And that reduces the amount of like logic you have to write that says, okay, is this thing present? If it's not present, if the name's different, all that kind of stuff. So yeah, this is taking a bit longer than I would expect for the first request, but I will kind of leave it to do its thing. I don't think I have a cached output, but yeah, I mean, we are almost running SmolVLM2. A couple other things about kind of multimodal dataset preparation is for an application like this, we usually test on like 50 to 100 different images to label. And that takes some time. But again, if you've got an application that's like already mapping images to some form of data, it's quite easy to get that data. We then usually train a first version, see how it goes, and then we would look at training kind of a second version. And in terms of running this on your own infrastructure, you can hit deploy. And then you'll automatically be given a code snippet that you can copy. And then this is when you run this code snippet, it'll take an input image, it will cache your workflow, and importantly, run on the serverless endpoint. And so we will kind of get that response that we're expecting. I will try one more time on this. And if not, we can move to Q&A. But yeah, very much this is a primitive of running multimodal models. We're excited to explore support for more models as they're released. Qwen and SmolVLM2 are kind of my go-tos right now for document processing. And here we go. Here is the result from SmolVLM. Now our weights are cached. So you can see the output of our classifier is document, continuous, return nothing. That's okay. And then SmolVLM gave us this big JSON output. And if I put that into a Python file, and I'm just gonna remove some things for demo purposes. Bring this over here, and then we will make it look prettier. Let's remove the backslash. And then let's put this into like a JSON prettifier here. I will put this back in Visual Studio. We have the results of our workflow. So took a little while, but we now have it. And here we can look on the left and then bring this to the right. So we've got the root number 8851VL185, the pallet number 19, and delivery date, all the information. And then we've also got that products list as well. So it's got the SKU number, it's got the products, even in the same capital cases for sales unit 64, everything is matching up kind of on this cursory look. And then, of course, if things weren't exactly as we'd expect, one, I'd look at data, just make sure everything is kind of the quality expected and is consistent. And then number two is like more data. But honestly, like we trained on 150 images and we've got this working on our own infrastructure on a cloud endpoint with a classifier that's running before it. Like that's pretty cool. And if I go back to my workflow again, and then if I upload this photo of the desk, this should take much less time because SmolVLM doesn't need to run. And it's only clip. But yes, that is to say, we just turned it. There we go. So SmolVLM returned nothing, not document, and we didn't spend time running additional compute on SmolVLM. And so with that said, we talked about combining these VLMs as kind of the heavy lifter of the task, but also doing a pre-classification step to make sure we're not wasting compute when we don't need to. And really great pattern to use. And with that said, thank you very much and join us for our next webinar, replo.com/webinar.